Hello everyone, I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in the video lecture series, I am going to discuss some of the topics in the subject thermal engineering, the concept of refrigeration and air conditioning. Topic name is refrigerant. So this is the presentation overview. So in this lecture series, we are going to discuss what is refrigerants and what are the classifications of refrigerations and vapor compression cycles and the key properties of some of the refrigerants, the properties such as thermodynamic, chemical properties, safety aspect and then the environmental aspects, and evolution of refrigerants and applications, domestic, commercial and industrial applications of refrigerants. And finally, we will going to discuss about the design thinking approach, empathize user needs and the regulations and ideate stage. So introduction to refrigerants. So refrigerants are the substance used in the refrigeration cycle, typically which undergoing the phase transition from the liquid to gas back to absorb the heat from one area and release it into the another area. So their properties are crucial for efficient as well as the environmental sound cooling and the heating systems. So some of the heat transfer mediums that facilitates the thermal energy movement and phase change properties that crucial for the effective heat absorptions. Then coming to the environmental impact, the modern focus on the low GWP and the ODP concern. So vapor compression cycle explained. The vapor compression refrigeration cycle is most widely used method for the air conditioning and the refrigeration system. It involves the four key components such as compressors, condensers and expansion valve and also evaporator. So these are the main key components that involves in the air conditioning and the refrigeration systems. So some key refrigerant properties are thermodynamic properties, chemical stability properties, safety concern as well as the environmental concerns. So selecting the right refrigerant involves the understanding the thermodynamic as well as chemical and the safety characteristics. These properties directly influences the system's efficiency and also directly influences the cost of the system and the environmental footprints. Coming to the thermodynamic properties such as a boiling point, critical temperature and the latent heat of vaporization. Chemical stability, the refrigerants should be in non-corrosive properties and compatibility with the materials and it should has the long lifespan. So in safety concerns, the refrigerants should be in non-flammable conditions and non-toxic condition and also the low pressure operations. Environmental conditions, the ODP is nothing but it is the ozone depletion potential as well as the GWP. It has the low GWP is nothing but low global warming potentials. So this is the evolution of the refrigerants starting from the 19th century to the present. So from earlier the natural refrigerants to modern the synthetics and back to the natural alternatives. The industry has continuously sought safer as well as the more efficient and environmentally friendly options. In 19th century, the refrigerants such as ammonia, carbon dioxide and sulfur dioxide is used in the usually in the industrial applications. In 1920s to 1980s period, the CFC is nothing but chlorofluorocarbon and HCFCs. These are the highly efficient, but the ODP concerns. ODP is nothing but in previous slide we discussed about the ozone depletion potential is concerned. In 1990s to 2000, the chlorofluorocarbons it has the zero ODP but high the GWP. In present stage, the HFOs natural refrigerants it has the low GWP as well as the low ODP. That means low ozone depletion potential and also low global warming potentials. So some of the current applications of refrigerants it is used in the domestic as well as the commercial application and also some industrial systems. In domestic and commercial applications such as refrigerators and freezers, air conditioning units in residential as well as the commercial buildings like office, supermarket display cases. In industrial system, cold storage warehouse, chemical process cooling and pharmaceutical manufacturing. These are some of the applications of refrigerants. So, design thinking approach. Coming to the design thinking approach, the first stage of design thinking is empathize. In refrigeration design, empathize means deeply understanding the user needs and environmental concerns, environmental issues and the regulatory process. This stage involves the extensive research into the existing system, user complaints and environmental impact assessments. Some of the criteria are user needs, environmental impact and regulatory landscape. These are the stages involved in the empathize of design thinking. Now, another stage of the design thinking is ideate. This ideate stage encourages the engineers to generate a wide range of the creative solutions for refrigerant challenges without the initial judgment. This can involve the exploring the novel chemical compositions or innovative system architecture such as brainstorming, system redesign and the material innovation. Through the material innovation, they explore the new components compatible with the eco-friendly options. Let us discuss one real-time case study which is used the R32 adoption. The R32, a hydrochlorocarbon, offers a low global warming potential GWP than its the predecessors. The R410A making it more environmentally conscious choice for the air conditioning system. Some of the benefits are given here: low GWP and higher energy efficient, and also it requires the less refrigerant charges. Some of the challenges are it is flammable and requires the specific equipment and the handling procedures. So this is the summary of this lecture video series, the future of refrigerants. The refrigerant industry is moving towards the sustainable solutions as well as the focusing on natural refrigerants and low GWP synthetic alternatives. So continued innovation is vital for meeting the global environmental goals while providing the efficient cooling through these criteria: sustainable focus, technological advancement and regulatory compliance. So these are some of the references I have go through for this concept. Thank you for your watching. Thank you.